We'll begin with talking about the satellites of the outer moons. All of the Jovian planets have many moons. We can see here some of the largest ones and their size comparison to Earth. And we see that some of these moons are fairly large. Now, moons are of very great interest to astronomers because they have more to tell us than the planets themselves do. If something happens to the surface of Jupiter, it's a fluid planet, and so the disturbance gets stirred up and forgotten. However, a solid surface has a lot more memory. So photographs of the moons of the planets are often much more useful than photographs of the planets themselves. The spacecraft that have visited the outer planets spend at least as much time looking at the moons of the planets than the planets themselves. Now, Jupiter currently has 63 natural satellites or moons. That number changes as more are discovered. And the four innermost, of course, are called the Galilean moons: Io, Europa, Ganymede, and Callisto. Now, except for Europa, all are larger than the moon. Ganymede is the largest moon in the solar system, and it actually has its own magnetic field. And they were formed in a process similar to the formation of the solar system. The density of the satellites decreases with distance from Jupiter. Io, we see here from pictures, is an active planet. Here is a cloud of a volcanic eruption, essentially liquid sulfur coming out of the middle of it, that was captured by a space probe as it goes by. Now, the reason it's so active is it has gravitational tidal forces from Jupiter and Europa that keep Io's interior hot. What's going on is, because one part of Io is closer to Jupiter than the other, it stretches, and then as it turns, it continues to stretch in different directions, causing the rocks to move across each other, and that friction generates heat, which keeps Io very hot on the interior. Europa has very few craters on the surface, and it indicates that there's some heating, probably by tidal forces from Jupiter, and maybe some radioactive decay of elements in the interior. The surface looks like a cracked egg, indicating that there's a flow similar to glaciers on Earth. And the heating is probably enough to keep a layer of water melted below the ice crust. So if we were to look at a cross-section of Europa, we say it probably has a metallic core and then a rocky interior, but with the ice layer on the outside, there's probably about 100-mile thick layer of liquid ocean under the ice. This actually is one of the reasons that Europa is one of the places in the universe, or in our solar system at least, where we want to look for other life, maybe something growing in the liquid ocean. Now, Ganymede and Callisto kind of look like the moon, with grayish-brown color and covered with craters. However, those surfaces are mostly ice, and we can see the craters are all white, so it's a dust covering on top of an ice ball, essentially, and whenever a crater hits, it blows that white ice out. Callisto may also have subsurface liquid water. Ganymede is less cratered than Callisto, indicating Maria-type formations, although tectonic movement can't be ruled out. Now, by looking at the average density of the Galilean moons, their interior is composed mainly of rocky material. Differentiation may have allowed iron to sink to the core. The rest of Jupiter's moons are much smaller than the Galilean satellites, and they're cratered. The outermost moons have orbits of high inclination, suggesting they're probably captured asteroids. They weren't created and formed in the same manner as the Galilean moons. Saturn has several large moons and a lot of smaller ones. And like Jupiter, most of the moons form a mini solar system, but unlike Jupiter, Saturn's moons are of similar densities, indicating they were not heated by Saturn as they formed. Saturn's moons have a smaller density than those of Jupiter, indicating that their interiors are mostly ice. Most moons are inundated with craters, many of which are surrounded by white markings that show it's shattered ice. And the moons also have several features that have yet to be explained. Here we see some pictures of that. Titan, which we'll talk about in a minute. Mimas, which looks like the prototype of the Death Star, has a very large crater on one surface. Some of the others have these strange formations, strange terrain that we're not sure about. But they're all different. They all are mostly ice. Titan is Saturn's largest moon. It's actually larger than Mercury and has a mostly nitrogen atmosphere. It has a solid surface with liquid oceans of methane. And the Huygens probe actually landed on the surface of Titan. The Cassini space probe showed many things about the surface, including rivers and seas. However, all these rivers and seas and dune surfaces, the liquid that we see in all these is liquid methane. Uranus has 5 large moons and several small ones that form a regular system. Moons are probably composed of ice and rock, and many show heavy cratering. Now, Miranda is a very unique moon, and it appears to be torn apart several times and reassembled. So something large hit it, broke it into pieces, and the pieces came back together. Triton's orbit is backwards and is highly tilted with respect to Neptune's equator. So Triton is perhaps a captured planetesimal from the Kuiper belt. Triton is large enough and far enough from the planet to retain an atmosphere. It has some craters with dark streaks extending from them, and at least one of which originates from a geyser caught in eruption when Voyager 2 passed it. The material in the geyser is thought to be a mixture of nitrogen, ice, and carbon compounds, heated beneath the surface by sunlight until it expands and bursts into the surface. Here we see the surface of Triton, and it's got some strange features, some wrinkled terrain. And this is a picture from Voyager 2, and we see here wind-blown volcanic debris.